let's explore some properties of a circle of radius 1 centered at the origin. These properties are useful when discussing trigonometric functions. The set of points of a distance 1 from the origin is a circle of radius 1. We call this the unit circle. We know the equation of the circle is x squared plus y squared is equal to 1. Notice I have labeled all the obvious points on the circle located on the x and y axis. What about those less obvious points not intersecting the x or y axis? Here we need the equation of a circle, as you can see with this example. The point negative square root of 3 over 2, comma y, is on the unit circle in the third quadrant. Find its y coordinate. To find this point, we use the equation of a unit circle, x squared plus y squared is equal to 1. And plug in x equal negative square root of 3 over 2. So we have negative square root of 3 over 2 squared plus y squared equal to 1. This gives us 3/4 plus y squared is equal to 1. Now subtract 3/4 from both sides. And we have y squared is equal to 1 minus 3/4. So y squared is equal to 1/4. Square root both sides. And we get y equal to plus or minus 1/2. Since the point is located in the third quadrant, its y coordinate must be negative. So y is equal to negative 1/2. Recall when finding the terminal point in any quadrant, we need only know the corresponding terminal point in the first quadrant. We use the idea of reference number to help us find terminal points. Let t be a real number. The reference number t bar associated with t is the shortest distance along the unit circle between a terminal point determined by t and the x-axis. Take a look at these graphs. To find a reference number t bar, it's helpful to know the quadrant in which the terminal point determined by t lies. Notice in the first and fourth graph, the terminal points lie in the quadrants 1 and 4, where x is positive. We find reference number t bar by moving along the circle to the positive x-axis. Looking at graphs 2 and 3, the terminal points lie in quadrants 2 and 3, where x is negative. Here we find t bar by moving along the circle to the negative x-axis. Now to an example. Find the reference number for each value of t. A, t equal to 5 pi over 6. B, t equal to 7 pi over 4. Now to find these reference numbers, we need to know which quadrant we are coming from. For t equal to 5 pi over 6, the terminal point lies in the second quadrant. We find the reference number t bar by traveling along the circle the shortest distance to the x-axis, which is the negative x-axis. For t equal to 7 pi over 4, the terminal point is in the fourth quadrant. So we travel along the circle from the terminal point to the positive x-axis. So for part A, the reference number is pi minus 5 pi over 6 equal to pi over 6. And for part B, the reference number is 2 pi minus 7 pi over 4 equal to pi over 4. So we found these reference numbers, and you're probably wondering what this has to do with finding terminal points. That leads to our next example. Find the terminal point determined by each given value t. The t values I kept the same as the previous example, including all the work we did to find the reference numbers. For part A, we had reference number t bar equal to pi over 6. This determines a terminal point of square root of 3 over 2, 1/2. Since the terminal point determined by t equal to 5 pi over 6 is in quadrant 2, its x-coordinate is negative, and its y-coordinate is positive. Thus, the desired terminal point is negative square root of 3 over 2, comma, 1/2. For part B, we had a reference number t bar equal to pi over 4. This determines a terminal point of square root of 2 over 2, square root of 2 over 2. Since the terminal point determined by t equals 7 pi over 4 is in quadrant 4, its x-coordinate is positive, and its y-coordinate is negative. Thus, the desired terminal point is square root of 2 over 2, negative square root of 2 over 2.